We've all seen it, right? A technology comes along, it's clearly better, but we just stick with the old way. Why does that happen?
Yeah, what keeps us locked in? Technologically, socially, maybe even economically.
Exactly. That's the big question we're diving into today. And it's a question you, our listener, helped shape with this really fascinating case study, global IPv6 adoption.
Absolutely. The sources you sent over gave us a fantastic starting point. It's a complex picture.
It really is. We've gone through, well, a lot of material academic research, industry reports, different country
Hmm.
experiences. It's definitely not as simple as better tech wins.
No, not at all. So, our mission for this deep dive is to really get under the skin of why IPv6 adoption has been so patchy, so uneven, even though technically it's pretty essential for the internet's
And
future.
I'll be looking at it through a couple of key lenses, right? Institutional dynamics and network effects.
That's the plan. And, even if the nitty-gritty of internet protocols isn't your usual thing, the patterns here, they apply much more broadly.
Yeah, definitely. We even stumbled upon a really interesting way to tie it all together, a perspective we're calling institutional network theory. But we'll get to that.
Okay.
Let's start digging in.
All right. Let's kick off with institutional theory. So, this way of thinking looks past just, technical efficiency.
It's not just about speed or capacity.
Right. It says technology choices are actually deeply embedded in social norms, regulations, the whole environment an organization operates in.
Okay, so it's about fitting in almost.
In a way, yes, it's about legitimacy. Organizations adopt things partly to look modern, to be seen as forward thinking.
Oh, like adopting the latest buzzword tech to show you're current.
Exactly, it sends a signal. And some really foundational work by DiMaggio and Powell back in the 80s actually outlined three ways this happens, three kinds of institutional isomorphism, they called it. Ways organizations start to look alike.
Isomorphism. Okay, what are the three?
First up is coercive. This is pressure from outside. Think regulations, government mandates, maybe even dominant companies setting the standard.
Like, you have to do this.
Pretty much. We'll see later how government action definitely played a coercive role in some countries' IPv6 rollouts.
Okay, that's coercive. What's next?
Then there's normative isomorphism. This comes from professional standards, from the experts. Think about training, best practices shared in an industry. What engineers learn is the right way.
So it's driven by the professional community itself,
Yeah.
like network engineers developing IPv6 expertise.
Exactly that, what the professionals value and promote. And the third one is mimetic.
Mimetic, like mimicking.
Yeah, basically copying, especially when things are uncertain. Organizations look at successful competitors or leaders and just do what they do.
Safety in numbers, kind of. If Google's doing it, maybe we should too.
Precisely. If a big content provider switches to IPv6 and it works, others might just follow the leader. It reduces their perceived risk.
Makes sense. But it's not always about adopting new things, is it? There's resistance too.
Oh, absolutely. That's institutional inertia. Existing routines, contracts, all that sunk cost in current infrastructure, it all pulls against change.
So the huge amount of IPv4 gear already out there.
Exactly. That's a massive factor. It creates this powerful drag. And what the research shows is without some big push like strong rules or a major shift in what's considered normal organizations, just didn't see much downside to sticking with IPv4.
It worked. It was familiar. Why rock the boat?
Right. The path of least resistance.
Okay, so that's the institutional angle, legitimacy, pressures, inertia. What about network externalities? That sounds more about how connected everything is.
It is, yeah. Network externalities or network effects is the idea that a technology gets more valuable the more people use it.
The classic example is the telephone, right? What
Yeah.
phone isn't useful? Millions are.
Exactly. Or social media today. The value comes from the connections. And we can split these effects into two types.
Okay.
There are direct network effects, like the phone example. More users directly mean more people you can connect with, increasing the value for everyone.
Simple enough? More people, more value.
And then there are indirect network effects. This is when more users of a platform, say an operating system, attract developers to make more stuff for it, like apps.
Ah, so the apps make the operating system more valuable, which attracts more users, which attracts more apps.
Exactly. It's a feedback loop. More users encourage complementary innovation, which makes the original thing even better.
Got it. So how does this play out in adoption?
Well, it often leads to this S-shaped adoption curve. At the start, with few users, there's low value. It's that coordination problem, the chicken and egg thing.
Why join a network if no one else is there?
Precisely. But if it gets enough users, it hits a critical mass. That's the tipping point.
And then adoption takes off.
It accelerates. Suddenly the value is obvious and you get this bandwagon effect. People jump on board partly just because it's becoming the standard.
Fear of missing out, but for tech.
You could say that, but the
Mhm.
flip side is lock-in. Once a technology is dominant, switching becomes really hard. High switching costs. Not just money for new gear, but also retraining people, changing processes, losing compatibility with everything built around the old standard.
Like the QWERTY keyboard example the sources mentioned.
Yeah.
Or VHS tapes.
Perfect examples. Neither was necessarily the absolute best tech, but they got locked in because of these strong network effects. Overcoming that inertia often needs a push.
Like subsidies or making sure the new tech works with the old.
Exactly. Strategic interventions to get past that initial hump and reach critical mass.
Okay, let's bring this back to IPv6. How did network effects shape its rollout?
Well, IPv6 was the technical answer to IPv4 addresses running out. Huge address space, better features, technically superior in many ways.
Right.
But its value depended on everyone adopting it. ISPs, websites, device makers, users. You needed the whole ecosystem.
The chicken and egg problem again.
Yeah.
No point having an IPv6 connection if the websites you visit are IPv4 only.
Exactly. So early on, the marginal utility, the extra benefit for any one player to switch, was pretty low compared to the massive installed base of IPv4. Plus, you had workarounds.
Like NAT, network address translation.
Right. NAT let multiple devices share one IPv4 address. It kind of kicked the can down the road, eased the immediate pressure.
So IPv6 was technically ready, but the network effects weren't there yet. And NAT reduced the urgency.
Precisely. It created this lock-in around IPv4. IPv6 was viable, but not compelling enough for many to make the switch. It stagnated for a while.
So what changed? What started the ball rolling?
Key players making big moves. The research points to large mobile operators, especially in places like India, launching massive IPv6 deployments.
Global first. Interesting.
And huge content platforms, think Google, Facebook, enabling their services over IPv6.
That would make a difference.
Yeah,
Suddenly there's content and users on IPv6.
exactly. It started that positive feedback loop, and events like the World IPv6 launch in 2012 helped to symbolically and practically.
A coordinated push.
Yeah. And since then, global IPv6 usage has been climbing, getting close to critical mass in some markets now.
But you said it's uneven.
Very uneven. Some regions, often driven by regulation or those mobile ecosystems, have high adoption. Others, especially maybe enterprise networks with lots of legacy gear, are lagging.
So hitting critical mass in one country doesn't automatically pull everyone else along.
Not necessarily. Network benefits can be quite local initially. If there isn't much traffic or content sharing between two regions, high adoption in one doesn't create a strong pull for the other.
So it took sustained effort, coordination, and these big players stepping up to overcome that initial inertia.
Absolutely. It wasn't just going to happen on its own.
Okay, institutions, network effects.
Yeah.
But the sources also mentioned this idea of a supernetwork and content segregation. How does that fit in?
Right. This adds another layer of complexity. Instead of seeing the internet as one big thing, think of it as super network. Lots of overlapping networks connected together.
Like company networks, ISP networks, content delivery networks.
Exactly, a network of networks. And within that, you get content segregation. People cluster around certain types of content.
Based on language or interests, like gaming communities versus local news consumers.
Precisely. These clusters can become quite distinct, quite dense internally. They might evolve technologically somewhat independently, even on the same basic infrastructure.
So what happens in one cluster doesn't automatically affect another.
Pretty much. If a whole gaming community goes IPv6, that's great for them, but it might not push, say, a business network focused on different applications to switch.
The research talked about network density. More connections inside a cluster than between clusters.
Yeah, content segregation increases that internal density. So an IPv6 heavy cluster can work fine internally, even if the rest of the internet is still mostly IPv4.
Like little IPv6 islands within the larger IPv4 ocean.
That's a good way to put it. And the type of content matters too. Big streaming services pushing lots of data have a bigger incentive to use efficient tech like IPv6.
Better performance, maybe lower costs for them.
Right. But if a cluster is mostly about, say, email or basic web browsing, the push isn't as strong. New clusters might even start out favoring IPv6, but their impact depends on how they connect to the older IPv4-centric ones.
So adoption isn't uniform. It spreads through these content communities differently.
Exactly. And this fragments those network effects we talked about. High IPv6 use in, say, China mainly benefits Chinese users accessing Chinese content.
It doesn't automatically make a user in maybe Indonesia want IPv6 if they mostly access different content.
Right. The network benefits become localized. Even global platforms like Google or Facebook see high IPv6 use where their content is popular, but that doesn't force adoption everywhere else if local content preferences differ.
So content segregation slows down that global convergence on IPv6.
It definitely can, yes. It makes the whole process much patchier.
Fascinating. Okay, so we have these layers. Institutions, network effects, content clusters. What does actor network theory bring to the table?
ANT, right. Yes, ANT. It offers a really different lens. It looks at how technology and society kind of co-create each other. And crucially, it treats everything in the network, humans and non-humans, as potentially influential actants.
Non-humans.
Yeah.
Like the IPv6 protocol itself.
Yeah.
Or a router.
Exactly. Engineers, regulators, users, they're actors. But so are protocols, hardware, software. ANT uses this principle of symmetry.
Symmetry, meaning
A piece of firmware on a router can shape what happens just as much as ISP's business strategy can. They all exert influence.
So it's not just people using tools. The tools push back and shape things too.
In a way, yeah. IPv6 is embedded in this huge network of diverse actors. ISPCs wanting profit, regulators wanting compliance, engineers wanting efficiency, routers needing compatible neighbors, all with different goals.
And IPv6 adoption emerges from how these actors align or don't align.
Precisely. Order, like widespread adoption, comes from aligning interests. ANT also talks about blackboxing.
Black box.
That's when a technology and its network becomes so stable and taken for granted you don't even notice them anymore. Like TCP/IP for most internet users. It's just there. It works.
You don't think about how it works.
Right. IPv6 is still in the process of being blackboxed. It's becoming more standard, but it's not invisible yet. Once something is fully blackboxed, changing it is really hard.
Because everything depends on it working that way.
Exactly. And another key ANT idea is translation. This is how actors frame a problem, offer a solution, and try to enroll others into their way of thinking.
Like the push for IPv6, framing IPv4 running out as the problem, and IPv6 as the only real solution.
Perfect example. They tried to make IPv6 the necessary path forward.
So who are the key actors or actants in the IPv6 world, according to ANT?
Well, you've got the ISPs controlling the pipes, governments and regulators who can mandate things, network admins and companies who might resist change.
The manufacturers making the routers and switches.
Definitely. Their support is crucial. Businesses deciding whether to enable it. End users whose demand or lack of it matters indirectly. And IPv6 itself, the protocol, offering a solution but competing with alternatives like NAT.
It's a whole ecosystem of actors influencing each other.
Exactly. And progress relies on getting enough of them pulling in roughly the same direction.
Which brings us back to those dependencies, the chicken and egg thing.
Right. From an ANT view, each actor's willingness to act depends on others. An ISP waits for content, content waits for users, users wait for ISPs.
A stalemate.
Until someone breaks it. Like when Google unilaterally enabled IPv6, that nudged ISPs. It enrolled them to some extent because their users needed access to Google.
So one powerful actor can shift the network.
They can. And even though users didn't ask for IPv6 specifically, the problems caused by IPv4 running out, like those carrier-grade NAT issues affecting performance, created indirect pressure on ISPs.
They needed IPv6 to maintain service quality.
Exactly. Businesses were often reluctant costs up front, benefits unclear if partners are still on IPv4, but then a government mandate can suddenly change their calculations.
Makes it a cost of doing business.
Right. And manufacturers, they follow the market and standards. Early on, lack of hardware support was a problem. Now it's pretty standard removing that barrier.
So adoption isn't just one decision. It's this ongoing negotiation between all these actors with different goals.
It really is. And things like NAT and T would see them as mediator actors. They changed the game, offered an alternative path, reshuffled the alliances for a while.
By reducing the immediate need for IPv6.
Exactly. But now the strain on IPv4 is growing, and the pro-IPv6 alliance, big content, mobile carriers, some governments is getting stronger, pulling more actors in.
Shifting from I'll do it if you do to Okay, everyone else is doing it, I better get on board.
That's the dynamic shift, yes.
So even with the tech available for years, it's these socio-technical factors, this whole web of interactions, that dictates the pace.
Absolutely. The technical solution existed, but the non-technical stuff created massive hurdles. That huge installed base of IPv4 gear, the expertise built around it, that's enormous legacy gravity.
Just the cost and time to upgrade or replace everything.
Huge. Plus training staff, changing procedures. For smaller outfits especially, the return on investment wasn't clear short term.
And running both IPv4 and IPv6 side-by-side dual stack, that doubles the work, right?
It adds complexity, definitely. Management overhead increases, and the fact that IPv6 isn't directly backward compatible means you need dual stack or complex translators. It's a burden.
And that just kept offering an easier, cheaper way out for a long time.
It did. It was the path of least resistance, technically and economically for many. It addressed the immediate symptom, lack of addresses, without requiring the fundamental cure, which was IPv6.
And for the end user, there wasn't a killer app, was there? No obvious speed boost or new feature they could see?
Not usually, no, so why demand it? It became a collective action problem. Everyone benefits if everyone switches, but no one wants to bear the cost of switching first.
Early adopters pay. Late adopters ride the wave.
Exactly. And without strong rules or industry mandates early on, it was mostly voluntary, driven by internal champions within organizations.
Plus, inertia inside companies. Maybe IPv6 wasn't a budget priority.
For sure. And the skills gap, too. Network engineers needed training, new expertise.
If it wasn't taught widely, it slowed down the supply of people who could actually implement it.
Right. And you also had some lingering myths or negative perceptions, maybe about security or complexity, that created doubt.
So it's this whole mix. Economics, skills, legacy systems, perceptions, lack of immediate user benefit.
All interacting to slow things down. A classic socio-technical challenge.
Okay, let's tie this back explicitly to ANT's translation idea. You mentioned the stages.
Right. So first, problematization. The IETF and others saying IPv4 exhaustion is a huge problem and IPv6 is the solution, making IPv6 the obligatory passage point, or OPP.
The thing you have to go through.
That was the goal. Then, interestimal. Trying to make IPv6 attractive. Developing transition tools like dual stack, running test days like World IPv6 Day Launch, making it seem less risky, more appealing.
Lowering the barrier to entry, showing it could work.
Exactly. Third stage, enrollment. Getting actors to actually sign up and play their part. Hardware vendors building it in, governments mandating it, major ISPs routing it, big content sites enabling it.
Each commitment making it harder for others not to join.
Precisely. And finally, mobilization, where the enrolled actors start acting together, making IPv6 part of normal operations. Groups like the Internet Society advocating for it. It's not fully stabilized yet, the translation isn't complete.
But it's got irreversible momentum in some areas, like mobile.
That seems clear, yes. The key ANT concept here is alignment. Getting the tech, the policies, the economics, the actors all lined up. That alignment was weak initially, but has grown stronger through these translation efforts.
So the current mixed IPv4, IPv6 internet is like a hybrid network, still finding its final form.
You could see it that way. A long stabilization phase. ANT also talks about irreversibility. IPv4 became highly irreversible. The IPv6 network is now building its own irreversibility. The end game is when IPv6 is the default and IPv4 is just legacy support. That completes the translation.
Okay, this framework really helps see the process. Now let's look at those country case studies. How did China, India, and Australia approach this differently?
They show very different pathways. China went for a strong, top-down, government-led approach.
Coercive isomorphism in action.
Absolutely. Their 2017 action plan set clear targets, mandated upgrades for carriers, data centers, government sites. They'd been preparing for years with things like the CNGI initiative, too.
And the main driver was just running out of IPv4 addresses.
That was huge. Very low IPv4 per capita. So the government pushed hard, especially on mobile networks. The big carriers upgraded rapidly. Fixed broadband was slower, but the mandate accelerated everything significantly after 2017.
A clear, state-driven effort. What about India? Their numbers are really high now.
India's story is fascinating. There were government plans and roadmaps from 2010, some later mandates for government sites, but progress was initially slow.
So not as top-down as China initially.
Not quite. The real game changer was Reliance Jio launching its massive 4G network in 2016, built entirely on IPv6 only.
Wow, IPv6 only from the start. That's bold.
Very. It was driven by economics, avoiding the high cost and scarcity of IPv4 for a huge new network and building something modern. They gained millions of users very quickly, and boom, India's national IPv6 stats shot up.
So one company's strategic move fundamentally shifted the national picture.
Absolutely. Other providers followed, and now India is a world leader, mainly thanks to mobile. It was economic necessity meeting disruptive private sector action within a supportive government framework. That 2016-2017 period with Geo was the key inflection point.
Incredible. Okay, third case. Australia. Different again.
Very different, much more market-led, less government intervention. The government encouraged it, led by example in its own agencies and academic networks, but no mandates on ISPs.
More normative influence, maybe mimetic later.
Pretty much. Telstra, the big incumbent, started deploying strategically across its networks from the early 2010s. Some others followed, but some big players lagged. It was driven by competition, corporate strategy.
Do they have the same IPv4 scarcity issue?
Not as acutely as China or India initially, so the incentive was more about future-proofing, long-term cost avoidance. It was a gradual climb.
No single big bang moment like Geo in India.
More like several smaller steps. Telstra turning on mobile IPv6 in 2016 was significant. The national broadband network rollout also helped create an opportunity for upgrades. By 2023, they were well above the global average, but through a slower, more organic, market-driven process.
3 countries, 3 very different stories shaped by their specific contexts.
Exactly. Which brings us nicely to this synthesis, institutional network theory, INT.
Right, the framework that tries to pull all these threads together. Tell us about it.
So INT emerged from realizing that neither institutional theory nor network externalities theory alone fully captured the IPv6 story. It needed both, integrated.
How does it integrate them?
It sees technology adoption, especially for infrastructure like the internet, as this process of coordinated decentralization. Lots of different actors making decisions, but needing to align somehow.
Coordinated decentralization. Okay.
It argues that adoption stalls or proceeds based on the interplay between institutional legitimacy. Does adopting this technology seem like the right, proper, expected thing to do in this context? And network criticality. How valuable and essential has the network become as more people and services join it?
So it's the combination of social pressure and practical network value.
Exactly. INT says you need both to overcome inertia. It helps explain why a globally agreed standard like IPv6 faces such hurdles, because you need alignment across multiple levels, regulatory, organizational, technical, and you need the network effects to kick in. It's about managing both legitimacy and criticality simultaneously.
That provides a really rich way to understand why something that seems straightforward technically can be so complex in practice.
That's the goal, a more holistic view.
This has been incredibly clarifying. So, wrapping up, the big takeaway is that getting a better technology like IPv6 adopted isn't just about the tech itself.
Not even close. It's tangled up with social norms, rules, the sheer weight of old infrastructure, those crucial network effects where value builds on adoption, how the internet itself is fragmented by content.
And that whole complex dance between all the different actors, human and non-human, trying to align their interests.
Absolutely. And this institutional network theory gives us a powerful lens to see how those institutional forces and network dynamics interact to shape the outcome.
It really does. So a final thought for you, our listener. Thinking about IPv6, what other big tech shifts happening now might be facing similar roadblocks? Where are the institutional hurdles? What needs to happen to reach critical mass or trigger that institutional disruption?
Yeah, where's that balance between the technical edge and the whole ecosystem needed to actually make it fly?
Something to ponder. This was a fantastic deep dive. Thanks for walking us through it.
My pleasure. It's a fascinating case study.